Another thing we can do with alkenes, and something that's industrially very important and something you use on a daily life, is radical polymerization, or at least the products of this, right? And so this makes a polymer. A polymer is a large compound that's made up of repeating units. And these repeating units are called monomers. Right, so maybe you can think of like a brick wall is made out of monomers of bricks. Polymers are also really important in biochemistry. Your DNA is a polymer of your nucleic bases. Cellulose is a polymer as well. And then all the proteins in your body are polymers of your amino acids, right? And so what you do is you take an alkene, you have some kind of initiator here to start some radical polymerization. We won't really look at the mechanism, but it's the same thing. Initiation followed by a whole bunch of propagation. We actually will take a look at the mechanism, never mind. You guys said that. But through a bunch of whole different steps, what you happen to do is you polymerize them, right? And so you can see this repeating unit of carbon-carbon found all throughout here, right? And so we will take a look at the mechanism, my bad. One thing we could do is add some peroxide and heat this. And so, of course, in our first step, we're going to form some peroxide radical. This can then react with an alkene. To form another radical. And then this alkene radical, or alkane radical right now, can further propagate. With other alkenes, right? And so if you have, and then branching can occur as well, as we see in this picture right here. So, right, you use this stuff in your everyday life. If you polymerize ethene, or ethylene is the old school name for it, you'll get polyethylene. If you just add a chlorine group here, then you'll have chlorines attached to every other carbon, and this is called polyvinyl chloride, or PVC, right? I'm sure you've heard of PVC pipes. If you not use them, right? Polyethylene also used, not as much, but still pretty popular. If we have this phenyl ring attached here, we get what's called polystyrene, which I'm sure you've heard of as well. If we just have all fluorines and we polymerize that, right, it's all going to be fluorinated. You'll get Teflon, right, which is used as non-stick, right, and it's non-reactive, right? These carbon-fluorine bonds, as we've seen, we don't really do much with them because they're super strong. And then if you just have a methyl group, you'll get polypropylene. And so pretty much all plastic, this is plastic, all of these are plastics. So your plastic bags, your plastic water bottles, a lot of your clothes are synthetic fibers. So there's just a whole lot of plastics in there, and there's a whole lot of jobs in polymer chemistry / engineering, right? How do you go from these molecular view of these things to these larger views? Why are some plastics hard? Why are some soft? That kind of thing. And so there's a lot of jobs. I remember looking at different jobs, and almost every other one was a polymer chemist, right? And so that's one big thing to think about. And then there's also, when we put all these plastics out there, they don't break apart too much. And so there's also big problems that are going to come from all of these plastics. And so there's big problems to solve in the future. So it's definitely a big field to go into, right? I'm sure most of you have heard of microplastics and whatnot. And so now you kind of know what they are, right? They're just basically really small components of these polymers.